In this problem, we want to find all angles theta such that the sine of theta equals 1/2. To do this, we first recognize that there are two angles theta in the interval 0 to 2 pi, such that the sine of those angles equals 1/2. They're located in the first and second quadrants because the sine is positive in the first and second quadrants. Well, what are those angles? Well, the first angle theta is pi over 6 because the sine of pi over 6 is 1/2. So what's the angle in the second quadrant? That's going to be 5 pi over 6. Again, the sine of 5 pi over 6 is also 1/2. Now what we have to do is recognize that the sine function is periodic with period 2 pi. In other words, if I go to an angle of pi over 6 and then do one complete revolution, the sine of that angle is also going to be 1/2. So, to write down all the solutions, we say it's the set of all theta such that theta equals pi over 6 plus 2 pi k, where k is any integer. So if we add any integer multiple of 2 pi, we're going to have an angle whose sine is 1/2, again because of the periodicity of the sine function. Likewise, if I add or subtract any integer multiple of 2 pi to 5 pi over 6, I'm also going to have an angle whose sine is 1/2. So I write my complete solution set as follows, where k is any integer. Now, if I want specific values of the angle theta such that the sine is 1/2, I just substitute various values of k into these formula. So for example, if k is 0, I would have that the angles are pi over 6 and 5 pi over 6. So that corresponds to k equals 0. If k is 1, I would have that the angle is pi over 6 plus 2 pi, or pi over 6 plus 12 pi over 6 is 13 pi over 6. Over here, if k is 1, I would get that the angle is 5 pi over 6 plus 2 pi, 5 pi over 6 plus 12 pi over 6 is 17 pi over 6. So this corresponds to k equals 1. If I let k equal 2, I'd have pi over 6 plus 4 pi. That would be 25 pi over 6. Over here, if I let k equal 2, I get 5 pi over 6 plus 4 pi gives me 29 pi over 6. So I've listed 6 specific angles whose sine is 1/2. They correspond to k is 0, k is 1, and k is 2.